Alright, welcome to the second clip. We were looking at measuring systematic risk. So this is the formula to measure systematic risk. This is beta. We use beta. Beta is measured this way. This is the formula for measuring beta. Okay, as I mentioned at the end of the last clip, the beta measure can range from negative infinity to positive infinity. But usually the central value, an important value, is beta is equals to 1. Why? Because this is what we call standardized by the standard deviation of the market. Therefore, if this is 1, so this multiplied by this must be equal to this. Alright, therefore, when that is the case, then this will become equal to 1. Right. So it says a beta of 1 implies the asset has the same systematic risk as the overall market. So that is an important value. When beta is less than 1, it implies that the asset X here has less systematic risk than the overall market. Okay, and if it is more than 1, beta is more than 1, it implies that the asset has more systematic risk. So remember that this beta is a measure of systematic risk, not total risk. Okay, only the systematic portion of an asset's risk. Okay, if it is greater than 1, then it has greater systematic risk than the market. Okay, if it has less than 1, then it has less than the market. That's the implication. So beta can be negative. If it is negative, what does that mean? It has systematic risk, but the systematic risk moves in the opposite direction compared to the market. If the market goes up, this goes down. But it still has a systematic risk, meaning the risk that cannot be diversified away. Because why it cannot be diversified away? Because it moves in the same direction as the market. Okay, in the same manner. And therefore, the risk cannot be eliminated. Okay, so that is the measure of beta. That's the implication of this measure of beta. Alright, so this is the covariance. I've explained that. This is the correlation between the two returns. The return of stock X and the market return. Alright, now this table gives you the beta coefficient for some of the more popular or famous stocks. For example, Apple. This is in 2017. So Apple's beta is 1.44. Johnson & Johnson is 0.67. So it means that Johnson & Johnson has about 2/3 of the market's systematic risk. The systematic risk of Johnson & Johnson is about 2/3. Okay, about 67% of the market's risk. Market risk is always systematic risk. Market risk has no unsystematic risk. Okay, so that is what it means. Now Apple has 1.44 times. It is more than the market risk. Usually higher the beta, it means that the stock has higher systematic risk. Is that okay? Alright, we move on. Now we look at in this example, total versus systematic risk. We consider the following information. You have two securities here, C and K. You are given the standard deviation as well as the beta. Now the question is, which security has more total risk? If it's total risk, then you look at standard deviation, because standard deviation is a measure of total risk. This is standard deviation of returns. So you find that security K has greater standard deviation, 30%, compared to security C. Therefore, you can say that security K has more total risk. Next question, which security has more systematic risk? Now, systematic risk is measured not by standard deviation but by beta. Therefore, we should look at beta. Which security has more or higher beta? So it's security C, right? So we can say that security C has more systematic risk. Now coming to the third question, which security should have the higher expected return or the required return? So this we say required return. Okay, if you want to invest either in security C or security K, which one would you, from which security you would require a higher return? of course it will be based on the beta. Yeah? Higher the beta means higher should be the required return. Why? Because this is not relevant in standard deviation. Why? Because standard deviation is a measure of total risk. It also includes risk that is unsystematic. Yeah? Based on the systematic risk principle, only beta is relevant. Okay, because this cannot be diversified. Yeah? This part of this can be diversified. Yeah? Even though security K has higher standard deviation, some of this can be diversified or eliminated. Yeah? But this one, even though it's 20%, a large portion may not be able to be diversified away or eliminated through diversification. Therefore, the beta is higher. Yeah? So, this one has more systematic risk, security C. Therefore, investors must be given more compensation for investing in security C than security K, because it has more risk that cannot be eliminated through diversification. Yeah. Alright, so we should choose security C as the answer. Yeah, security C, not security K. Is that okay? Alright, and this is based on the systematic risk principle. Alright, now we move on to the next part. Okay, since we are given the beta for each security here, the beta is already given. Yeah? You don't have to compute this. Okay, you are considering the previous example with the 4 securities, a portfolio made up of these 4 securities. And here you are given the weight. We have computed the weight before, earlier in the class. Yeah. Alright, but here you are given additional information. The beta for each security is given. Is that okay? Now, what is the beta of the portfolio? Given the beta of the individual assets in the portfolio, you can compute the beta of the portfolio. This is the formula for the beta of the portfolio, which is similar to the expected return of the portfolio. Yeah? Okay, so the beta of the portfolio is equal to the sum here from x equals to 1. X here remains is the component security or component asset in the portfolio. Yeah? This will be the securities included in the portfolio. So x from 1 to capital X. Yeah? So here there are 4 assets. So 1, 2, 3 and 4. Yeah? So this capital X will be 4 here. Alright, so this is made up of the weight. This is portfolio weight. Portfolio weight is the proportion of investment in the portfolio that is made in a particular stock X. Yeah? So that is what this X here means. Multiplied by the beta for the particular stock. So here it will be 0.133 multiplied by 1.685 here, plus 0.2 multiplied by this, plus 0.267 multiplied by 1.161, plus 0.4 multiplied by 1.434. Yeah? So you sum all the 4 elements, you get the beta of the portfolio. Yeah? So the beta of the portfolio is simply the weighted average of the individual assets beta in the portfolio. Yeah? Individual asset, or the beta of the individual assets in the portfolio. Is that okay? Alright, let's move on to the next part. The beta and the risk premium. Yeah? Remember that the risk premium, so we introduced this new term here, risk premium. Okay, risk premium here first. Yeah? Let me just get the pointer. Now this risk premium is actually the expected return minus the risk-free rate. Yeah? You can use expected return or required return. Yeah? It doesn't matter. Okay, so it's the difference. Yeah. Now we also introduce this new term here, risk-free rate. This is the rate of return where there is no risk. Yeah. So here we can assume that the investment has no risk. Yeah. There are some investments that have no risk. Yeah. For example, government securities. Okay, treasury bills. This has this kind of investments have no risk. Yeah. Why? Because the government does not default. Yeah. Usually they will pay on time and they will pay as promised. Okay. Alright. So therefore these are called risk-free investments. Yeah? There are no risk here. Yeah? But other investments have some risk. Yeah? For example, stocks. Okay, usually risk-free investments are government-issued debt securities. Okay, so the difference between the stock's expected return or the required return minus the risk-free rate, okay, of return would be called the risk premium. Yeah? Premium here means how much the investors must be paid in addition. Yeah? That is why it's called premium. In addition, extra, yeah? Due to the risk involved in the investment. Okay, that is what this risk premium indicates. Alright, the higher the beta, the greater the risk premium should be. Yeah? This we understand, yeah? By intuition. Yeah? If you have to take higher risk, then you have to compensate with higher risk premium. Now, can we define the relationship between the risk premium and beta so that we can estimate the expected return or the required return? Yeah? So the book uses expected return throughout, yeah? But I think it is better to use required return when we determine, yeah, the return based on risk. Okay, expected return will be just the return based on expected cash flows, yeah. But when we determine the return based on systematic risk of an investment, then it should be called required return, yeah. But at equilibrium, okay, the required return must be equal to the expected return. Yeah? So we assume that the market is at equilibrium, meaning the price of the investments, yeah, or the price of the securities are correct, fair. Therefore, the required return must be equal to the expected return, yeah, at equilibrium. Yeah. So here they use this. We can use this term expected return or required return interchangeably, yeah, because we assume that there is equilibrium. All right. Yeah. So we can define the relationship. How do we define? Okay. We define it this way. Yeah. We can take the reward to risk ratio. And this is the slope of the line illustrated in the previous example. Yeah, we call this is the risk-free rate. Let's say it's 8%. Stock A has the expected return of 20%. Yeah, so this is the difference. Okay, this minus this will be the risk premium for stock A. Yeah, okay, 20 minus 8 will be the risk premium for stock A. And then if you look at the systematic risk, yeah, risk-free rate has 0 beta, because there's no risk. But the systematic risk for stock A, let's say it's 1.6. Okay. Now we want to compute the reward to risk ratio. It should be 20 minus 8 divided by 16. Oh, sorry, 1.6 minus 0. Yeah, so you get 7.5. This is the risk reward ratio. Okay. Now, what if an asset has a reward to risk ratio of 8? Okay, let's say this is 8. This is 7.5. But let's say you use another asset. You have another asset that has a reward to risk ratio of 8 rather than 7.5. Yeah? That means for every risk, yeah, every unit of risk, the asset is being rewarded. Yeah? The investors of the asset are being rewarded with higher reward, yeah? Because 8, not 7.5. When the unit of risk is the same, yeah? 1 unit of risk, right? So reward here is higher because it's 8. So what happens? This that means everyone would want to purchase this asset. Okay. Okay. Why? Because this asset is underpriced. All right. This is underpriced. What if an asset has a reward to risk ratio of 7? Yeah. This one, the benchmark is 7.5, but this is 7. Yeah. Nobody would want to buy because for the same unit of risk, the reward here is only 7%. Yeah. Okay, so 7% is lower than 7.5. Nobody would buy this. Okay, because the asset will be overpriced or overvalued. Okay. Now, this, if it is underpriced, it is above the line. Okay, above the line. Yeah, we will be seeing this line here. The next, higher relative reward compared to risk means the asset is underpriced. Yeah. Okay, if it is lower relative reward compared to risk, then it is overpriced. Yeah. Okay. Now, higher the relative reward, okay, or return, yeah, corresponds with lower price, yeah, relative to value. Yeah. So it is underpriced. lower the relative